In this video, I'll be creating this. It's 4 fully 3D printed 7-segment displays designed by this guy. And I'll be using them to create a mechanical digital hybrid clock. This project will be part of a series where I build stuff out made by other creators in hopes of eventually being able to create cool stuff on my own, like this. Alright, let's get started. So first, we have to print everything. Engineezy recommends using PLA filament, but you can probably safely use any other filament. For my project, I'll be using matte black PLA filament from Bamboo Lab. I also use blue filament from Bamboo Lab, and that'll be for the servo attachment and the segments. We'll get the STL files from Engineezy's website, import it into our slicer software. In this case, I have a Bamboo Lab printer, so I'll be using Bamboo Studio. Printing just the main part took about 8 hours, and with the servo attachment, it was 9. The segments use 2 colors, so I added a pause in the slicer software to swap filaments on a specific layer. If you're like me and don't have a printer that automatically switches filaments for you, you'll have to do this. Once everything is done printing, we can get started on the assembly. The main pieces of the 7-segment display is the encasing, the followers, the cams and camshaft, and of course, the 7 segments. I won't be going into detail with the assembly because Engineezy already has a video for that, which is linked in the description, but I'll do a quick overview. First, you'll want to get all the followers into the front plate and secure each one with a rack and C-clip. Then, align the followers with the back plate, then clip it into place. With the encasing done, assemble the cams onto the camshaft and wiggle it into the encasing. If you're struggling on this part like I did at first, I'd recommend setting the camshaft to the 5 position before inserting it. The colors on the segments were wrong, so I had to go back and reprint them. After fixing that and securing the segments in place, it should look like this. We now have a fully functioning 7-segment display. I really struggled getting the camshaft into place for the first time, but was really relieved at the end when I finally got it. Now that the main assembly is done, we can get started on the electronics and coding. Since I'm learning as I go, I ended up changing quite a bit of the circuitry that you'll see here, including not using a breadboard for the motor circuitry because it's unsafe due to its current rating. I'll give more details on the final circuit later, but to initially test everything, I connected my power supply, which was 2 18650 batteries providing 7.4 volts, to a buck converter to bring it down to 5 volts to be used by the servo. I attached the ESP32 to the breadboard to connect all the grounds together. Then I wrote up some code that just sweeps the servo back and forth, then got this. Still nothing. Yeah, so it didn't work the first try. While troubleshooting for an hour or two, I realized that I put the wrong values for setting the control pin in the code, had the wrong pin connected to the servo, and had the wrong pins connected to ground. With those out of the way, I then got this. Turn this on. Oh my god. Finally! Now that the servo is confirmed working, we can assemble the servo mount. Next, we attach it to the back of the display. Then get back to coding. I figured out the servo angle that corresponds to each number on the display, then updated the code to be a simple counter. Now all we have to do is build 3 more of these and we have a clock. After printing and assembling them with the different connecting pieces, we get this. To get the time functionality working, we connect the real-time clock module and update the 4 servos based on that. Just as a demonstration, I've set the 2 on the left to represent minutes and the other 2 to represent seconds. Two extra things I did for this project was create an enclosure that kind of neatly housed the electronics, and I also created a web server to use as a control panel to make debugging and controlling the displays easy. The download link for the enclosure is in the description, and if you decide to print it, just know that the supports are kind of annoying to remove. I accidentally broke this piece off when doing it. It looks like this when it should look like this. Anyway, the web server shows data for it and allows you to edit the servos in 2 ways, PWM values and the numbers shown on the actual display. You can change them individually or all at once with an auto-incrementing counter or set it to track the current time. For those of you who plan to download the code, I split the logic into different files and added a lot of logs to make it easier to understand exactly what's going on. You also need to download these libraries for the servo and real-time clock module. I tried finding a good dedicated 5V 10A power supply for this project on Amazon, but they all basically couldn't output a consistent 5V whenever current is drawn, so I ended up buying a bench power supply with banana plugs. Now, that's the end of the build. The final circuit includes a PCA 9685 module to drive the servos and power its own chip and the microcontroller. I'm using the ESP32's 3V pin to power the real-time clock module. Probably not the best idea to use the servo controller as a power rail, but it makes the wiring simpler. Here's the circuit diagram. The parts and code I used in this project are in the description. If you're thinking about making this yourself, just keep in mind that the displays can randomly get stuck and aren't really reliable when running them for more than an hour or so. And so many more issues. All in all, I learned a lot from this project, so I'd consider this a success. Thanks to Engineezy for designing these awesome displays, and thank you for watching.